All right, let's talk about a problem that sounds almost impossible for AI. We see AI doing incredible things, writing code, making art, you name it. But what about a task that isn't just hard, but is mind-bogglingly long? A task that needs over 1,000,000 steps, and every single one has to be perfect.
Check out this number, 1,048,575. That's exactly how many moves it takes to solve the classic Towers of Hanoi puzzle if you have 20 disks. It's a task that requires absolute, flawless perfection, step after step after step.
And that really brings us to the core question here. How on earth can an AI pull off something with over 1,000,000 steps and make 0 mistakes? I mean, think about it. One tiny slip-up, just one wrong move, and the whole thing comes crashing down. So, how is that even possible?
To figure out how they pulled this off, we first got to understand why this is such a monster of a problem for even the most advanced AI we have today. Let's really get into it.
Here's the thing you have to remember. No AI is perfect. Not even close. The biggest, most powerful large language models, the ones like ChatGPT or Claude, they all have this small but constant chance of messing up. It might be a tiny, tiny fraction of a percent, but that chance of making a mistake is always there.
And this is where it gets kind of crazy. That tiny little error rate, it compounds. So let's say you have an AI that's 99% accurate on any single step. That sounds pretty good, right? Well, if you ask it to do 1,000 steps in a row, the odds of it getting every single one of them right drops to almost 0. It's like trying to flip a coin and get heads 1,000 times in a row. It's not going to happen.
And this isn't just some abstract idea, right? We see it in the real world. This chart shows what happens when you actually test top-tier AIs on that Towers of Hanoi puzzle. For 5 or 6 disks, we're talking under 100 steps, they do great. But look what happens next. The second you bump it up to 7 disks, which is just 127 steps, damn, the success rate hits 0. They fail every single time.
So if our best AI models are basically doomed to fail at these long tasks, what do? Just give up? Well, no. A group of researchers came up with this completely different and honestly kind of counterintuitive strategy. They built a system called Maker that instead of chasing this impossible goal of perfection, just embraces the fact that AIs make mistakes and builds a really clever system around that fact.
It all boils down to 3 simple ideas. First, you decompose the problem. Second, you let a bunch of AIs vote on the right answer. And third, you red flag any answers that look weird and just toss them out. Let's see how that all comes together.
Okay, that first step has a bit of a mouthful of a name, Maximal Agentic Decomposition. But all it really means is that instead of giving one AI this giant 1,000,000-step headache, you just smash the problem into 1,000,000 tiny, individual, single-step jobs. And then you give each one of those little jobs to its own AI agent.
But just smashing the problem up isn't enough. The real genius, the real magic, happens when you start adding redundancy into the mix.
This quote just hits the nail on the head. We all think our computers are perfectly reliable, right? One input always gives you the same output. But deep down, at the physical level, they're making tiny mistakes all the time. Single bits of data get lost or flipped constantly. The only reason your phone works is because of non-stop, built-in error correction. The Maker system just takes that fundamental idea from computing and applies it to how an AI thinks.
So, for every single one of those 1,000,000 tiny tasks, the system doesn't trust just one AI. Oh no, it asks a whole group of independent AI agents to solve the exact same little problem, and then it looks at all their answers together.
And here's how that voting actually works, which is super clever. The system gathers up all the answers from the agents, and it only accepts a final answer when one option is clearly winning. Say it has 3 more votes than any other answer. This method gives you this incredibly high level of confidence. So even if a few of the AIs make a random mistake, the overwhelming consensus from the majority just filters those errors right out.
But there's one last layer to this whole thing, a final quality check. The system doesn't just blindly count every vote that comes in. First, it decides if a vote is even worth counting at all.
This is called red flagging. Think of it like a bouncer at a club. If an AI's response looks even a little bit weird or confused, it doesn't even get in the door. It gets tossed out before the vote even happens. This is so important because it gets rid of the most obviously wrong answers before they have a chance to mess up the results. So, what gets an answer red flagged? Well, a couple of big things. First, if the answer is way too long. For a simple one-step task, a long-winded response is a huge sign the AI is confused.
that it's just rambling, that's a red flag. Another big one, bad formatting. If the system asked for the answer in a specific way and the AI can't even do that, it probably didn't understand the assignment. In both cases, if the output looks wrong, the thinking behind it is probably wrong too. So you just throw it out.
So you take this whole system, you break down the problem, you make the AIs vote, and you throw out the bad answers. What happens when you finally point it at that impossible, million-step puzzle?
This is the result. It worked. I mean, it worked perfectly. This is a real snapshot from the system, almost 500,000 steps in, just cruising along. It finished all 1,048,575 steps with 0 errors. That task that was literally impossible for a single powerful AI, this system solved it flawlessly.
And here's the absolute best part, the kicker. They didn't need some massive, state-of-the-art, super expensive AI model to do this. Nope, because each individual task was so tiny, the system could just use a smaller, much more affordable AI for all the heavy lifting. It wasn't about the raw power of the AI. It was about the intelligence of the system around it.
And this is so much bigger than just solving a tricky puzzle, you know? This could actually point to a whole new way of building AI in the future.
For a long time, the main playbook in AI has been just go bigger, build more powerful, more intelligent, and way more expensive models. But this research suggests there's another path. Not bigger models, but smarter systems. Instead of one giant AI, you build what the paper calls, and you gotta love this name, Massively Decomposed Agentic Processes. Basically, systems of many, many smaller AIs all working together.
And you can see why this is so appealing, right? First off, it's safer. Each little agent only knows how to do one tiny thing. It's also way easier to check its work and control it. And, like we saw, it's just incredibly efficient. You're using cheaper AIs to get a result that the big, expensive ones couldn't even touch.
So it really leaves you with this fascinating question. As we keep pushing to build more and more powerful AI, is the goal to build one single giant superbrain? Or is the real path forward to create a superorganism, a million tiny, focused minds, all working together in perfect error-corrected harmony? It's a whole new way to think about what intelligence really is.